The final function operation with which we want to be familiar is finding the inverse of a function. Now, we are going to keep our examples relatively simple because we don't want to overindulge ourselves on the inverse when we really just need to be able to look at this right now for lines and maybe some other slightly more complicated functions. But right now, we're going to focus our attention on lines, and we're going to look at really simple functions. So a couple things you want to notice about an inverse before we get into defining it. We write the inverse of a function as f of what looks like -1 as a power. That does not mean the reciprocal. That indicator of -1 is simply an indicator of us finding the inverse. That's simply just the notation that we use with function notation. You're used to the -1 being a representation of the reciprocal, the idea of flipping over a fraction and switching the numerator and the denominator. That's not what's happening with inverses of functions. Inverses of functions are a little bit different. When you calculate the inverse of a function, or when you determine the inverse of a function, what you're actually doing is you are switching the domain and range. You are taking the group of numbers that make up the domain, and you are turning those into the range of the function. And you are taking the range of the function, and you are turning those into the domain. You are essentially switching the inputs and the outputs. You are saying, I no longer want to go from X to Y, the set that is allowed for X, to the set that is allowed for Y. I actually want to go the other direction. So what was previously your input and your output will now be your output and your input. Now, if you think of every function that we've worked with so far in this course, all of them have had the output over here as the isolated variable. That's a part of what makes a function a function. If you want to reframe a function as its inverse, you have to reorient the way you think about it. This is, if we're going to switch it to its inverse, this is no longer the output variable, so it can no longer be by itself. This is no longer the input variable. It needs to be by itself now as the output. So the steps that we're going to take in order to solve these are really just a matter of solving for the right variable, as this is now our output. So if we take our original function, y equals of 11x minus 12, that's a line, slope of 11, y-intercept of -12. You can envision what that would look like. We are now going to treat this function in an effort to determine its inverse, where this is the output and this is the input. So it's this variable, the x, that needs to be by itself. So we're going to add 12 over to the y, and then we're going to divide by 11. And you could write that a number of different ways. Y over 11 plus 12 over 11. You could separate it into two fractions, or you could just leave it like that. And this is what we call the inverse. We have reversed the rules of the domain and range. Now, if we want it to be a true inverse and we wanted to graph it and we wanted to graph it against the original function, the calculator doesn't know that you switch the variables of this original inverse function. So when you graph it, you do have to rename both of the variables so that a calculator is going to know that this is your output and this is your input. And that's where we go, that's where we run into the issue of, well, why can't I just use the calculator to do everything? This would be an instance of, if you tried to graph this function right here, this equation right here, you try to put those XY pairs into a graph, it would look identical to that because all you did was move the pieces around. You move the 12 and you move the 11, you did all responsible mathematics. The calculator doesn't know that. The calculator doesn't know that you are choosing to represent this as your output and that as your input now. The XY axis, as much as we want to call it an XY axis, is really an input-output graph. So if we want our outputs to be reflected in the same way for this equation as they were for this equation, then we need to re-letter them before we graph. And there's a couple more parts of this activity where you're going to see what that looks like, and it potentially can make it a little bit easier for you. So we want to take the time, you want to make sure you take the time to go through those activities. But when we're graphing this and we're thinking about the inverse of a function and we're switching the domain and range, sure, that's the path you take to solve it. You've reoriented how you're thinking about the variables. But if you went to graph it, the calculator, Desmos, a graphing calculator, whatever it is, isn't going to know that that's what you're doing. So you need to make sure that you reassign X and Y as the inputs and outputs even after you've made those changes. So make sure you go through the rest of the parts of the lesson. In the demonstrate section of this lesson, there's a lot of practice for changing inverses and looking at the graphs of inverses and thinking about what those graphs will look like.